In this example, I'm asked to solve when I have the binomial a minus 3 times the binomial a minus 5 equals 8. Well, what type of equation is this? On first glance, it kind of looks like half my work's done because the left-hand side is nicely factored. And unfortunately, what students do when they see this, they go, oh, it's factored. I'm going to set each of my factors equal to 8 and then solve it. If you try to do that, what you're saying, if you have two numbers multiplying to 8, one of them has to be 8. Is that true? No, 4 times 2 is 8. So the property you're thinking of, if you try to do that, is the zero factor property. But to do that, I must have 0 on one side. Because if two numbers multiply together equaling 0, one of them has to be 0. So what I'm going to have to do in this problem is simplify the left-hand side by FOILing out these two binomials. So, FOIL. First, a times a is a squared. Outer, a times negative 5 is negative 5a. Inner, negative 3 times a is negative 3a, and last, negative 3 times negative 5 is positive 15. So that's my left-hand side, and that equals 8. So now you can see the highest exponent on my variable is a 2. It's a quadratic equation, so I need everything on one side and 0 on the other. And I also need to simplify over here. So I'm going to have to subtract 8 from both sides so I can get my 0 on my right-hand side. And so I'm going to have a squared. Negative 5a added to a negative 3a is negative 8a. And then 15 minus 8 is positive 7. So now I have my quadratic equation in standard form. That means it's in descending order, and I have 0 on the right-hand side. So now let's take a quick look at our steps for solving an equation by factoring. I've written my original equation here and the work we did on the previous slide of getting a squared minus 8a plus 7 equals 0. So what are the steps in solving a quadratic equation by factoring? We need to write it in standard form, and that's what I did on the previous slide. This is in descending order equaling 0. The next thing I need to do is factor. So when we factor, we compare it to ax squared plus bx plus c. And a is the coefficient of the x squared term. Well, what number are we too efficient to write in front of that a squared? It's a 1. So a is 1. B is the coefficient of the x term, or in this case, the a term. B is negative 8, and c is the constant. It is 7. So we multiply a times c. It's 1 times 7. Is 7. So I'm looking to find two numbers that multiply to AC, which is 7, and add to B, that is negative 8. Since my two numbers multiply to a positive, that says the signs are the same, and if it adds to a negative, both of them have to be negative. So I'm going to start with negative 1 and negative 7. Those multiply to positive 7. And negative 1 plus a negative 7 is negative 8, which is the number I'm looking for. Now, if my a term was not 1, I'd have to break the middle term down into these two. But since my leading coefficient was a 1, these are my factors. So this is going to factor to a minus 1 times a minus 7 equals 0. So I've now factored it. Now we set each factor equal to 0, because remember, two numbers multiplied together equaling 0. One of them has to be 0, but remember that only works if this is a 0. So I get a minus 1 equals 0 and a minus 7 equals 0. This first equation, a minus 1 equals 0, add 1 to both sides, you get a equals positive 1. And the second one, a minus 7 equals 0, add 7 to both sides, you get a equals 7. And don't forget, can you check any equation you get on an exam? Yes, what you do is you plug a equals 1 into the very original equation, see if you get a true statement. Then you plug a equals 7 into the original equation to see if you get a true statement.